Okay, so hello, this is a tutorial for like beginners who wants to try Zigs. So this tutorial is will start from scratch trying to install Zig and try to debug in Visual Studio vscode. The first step would be to click around the direct download pages. So for Windows, you're gonna download this, put this somewhere on your machine. So for me, it's going to be here. So you see there's an executable here. So we give that to the path in your path first. So you find your path somewhere here, and you'll add the path where the executable is there. So as soon as you have this, you'll be able to start a console and execute Zig. So this is what the executable looks like. So it's just a simple executable like this. And so then you go make yourself a little directory, for example, Zig project, and make a new project. So I'm gonna do a new project now. So the trick for this is to just say Zig init exe. This guy here initializes a Zig build application in the current working directory. So let's call this hello Zig. Boom. No? You want I guess I need to go in a directory. Let's make there hello Zig. Yeah. Hello Zig like this, and now if I just do this just like this, boom, ls, what happened? So we got this new thing, hello Zig here, and there's a build and a source. So what I'm gonna do is go in Visual VS Code and say open folder, and it's this guy here, select folder. So we'll see the file. So there's gonna be this file got generated. You see this file here and this other file. So this is the hello world in Zig. So we'll talk about it later. Now I'm gonna just show how to build this. You see here they said created build Zig, created next try Zig build or Zig build run. Zig build. What happened? Oh, new directory appeared here. With this, wow, big cache of things. And then Zig out, and in Zig out there's hello Zig.exe. So the first step for me is to be able to run with F5 in the Visual VS Code. So I want, when I press F5, I want to build and run and be able to put little breakpoints there. So for this, you need to add some things in VS Code. And use something called the ZLS server. So it's this thing. So you'll have to go here, ZLS Zig LSP implementation, Zig tools. So this guy here, Zig language server. So now it's failing, but there's a way to there's ways. So the trick is to just I guess we want to build this. So you're gonna run this, and then Zig build release safe, and then config. I guess, yeah, so I did that, I think. So, and then it's gonna look like here, I've put it there, and it gives you this, and in Zig out you have bin ZLS exe. So now in your extensions, you'll need this extension first. It's called C++. This extension makes it possible to debug anything that looks a little bit like C or C++, which is the case for Zig. So you'll install this, and then in the extension settings, I guess we don't need things. I don't know. And then there's another one. So Zig, language support for Zig. That seems useful. So you can give things that build blah, blah, Zig path. So you see here my Zig path. So I've also added to this extension. So that's the path for the executable for Zig. And then ZLS for vscode. There's also an extension for this one. And in the extension settings, you give the path here to zls.exe that got made when you built ZLS using these. So you can configure. I think I forgot to configure it. You know what? I'm going to try to configure it right now. What happens when I go in here and see yes, so in here, if I do what they suggest I do here, zig out bin zls. Zig out bin zls config. Welcome to the configure. Yes. Then okay. vscode. Okay, let's say yes. Style warning, okay. Semantic highlighting, yes. These completions, okay. That sounds cool. VSCode setting, man, that's what I just discussed. This guy. So this is this. So now when I'm going back to my main here, I still need things so that F5 I wanted to launch the executable using a launch setting. So for this, I'm gonna copy paste the one I already had when I did that before in here. So in VS Code, you see there's these two files here, launch and task. So you'll have to somehow, I'm copy pasting this to my new directory, hello Zig. Is there a the whole thing, VS Code, boom, I don't care, hello Zig, can I get the whole VS Code here? And launch JSON, so there's launch, so look at this and copy paste this in a file called launch.json in under VS Code. Workspace order, zig out, bin nouveau. So that nouveau was the name before, so now it's called hello zig. Run this in integrated terminal. Pre-launch task. This one is fun because now when I press F5, it's going to launch a build before, and the task build needs to exist, and it's one of the tasks. So that's the file launch.json. So I'll save this, and then tasks. Looks like this. I'm not sure that's the best way. I found this somewhere on the web. I don't really know how VS Code works, so I don't know. This worked. So kind build. The command is zig build. So I guess here we could have arguments. So it's let's go back. So zig build. So that's what the command that's gonna get run. And after that, it's gonna call run. So I guess zig build run. The run will be like done differently because we want to, wow. We want to run with this because we want to debug it. So with GDB and everything and breakpoints. So just like this, zig build, blah blah. So this should work. So now I'm here and I press F5. Oh, press F5. What happened? Can I see terminal or something? Terminal, appearance, layout, extensions. Can I do go view selection terminal, new terminal? Boom. Run and debug. Please try to run and debug. Maybe I should restart this. If I just restart vscode. Configuration. Oh, something. Wow. 5, come on. Ah, it worked. So F5 worked. So now can I put a breakpoint here? Please let the breakpoints work. Yes. Ah, so we have breakpoints. So I can so the way I set it up in my VS Code, I've set my preferences for the key, like F4 to step over and F3 to go in and all of this. So that's what happens when I put breakpoints and want to step over and see the variable names. You'll see them here somewhere. Preview extensions. So this, I guess, should be over there. Can you go somewhere else? Go to the right? Yes. Something like this. Something like this. And as soon as I start, boom. I don't care. So it worked. Can we see the name of the variables somewhere? View, appearance, show status bar, activity bar, word wrap, appearance. Okay, so here, the locals, yes. Okay, so that's it for this. So now we're able to debug and see what's happening. So what we're going to do is to learn Zig. So that the first step would be to go through some tutorials somewhere. The fun one is the Ziglings. It's called Ziglings. So go to Ziglings. Learn the Zig programming language by fixing little problems. So go here and yes, we'll go through all of these very quickly. So the first thing I guess is to look at this. So that's the main the hello world in Zig. So any error, void, I don't know. We'll see what this all means. So log info. Okay. So let's look at their hello world here. So their hello world looks like this instead. So that's another hello world. Yes, that's another way of debugging. Here it's just void, so there's no error. So yes, so this also works. Needs to be up, you see. Oh no, this program is supposed to print hello world, but it needs your help. Zig functions are private by default, but the main function should be public. Okay, so we need to fix this program. So we need public. So yeah, so that's the syntax for functions. So could decide to make it public to be able to call it from elsewhere. The entry point is main. There is turn value is after, and then we call this. One thing I guess, like this function here, you see const. everything starts with const. So if I say here const high, and I want an I32, so an int 32, and say that it's equals to 42. So that's how to declare an int. And then a function like this std debug print, I would say const print std debug print. So like that's just an alias, and I'm defining a function here with const. So when you see const, it's just you create something that will not be able to change. So I can't say high equals to something else after, because it's const. So that's why it's always, if you want to see where something is defined, you just say const and then the name, and you grep for this, and you'll find the things. So that's why there's const everywhere. So like you define a struct, it's going to look like this: const my thing, and you're going to say it's equal to struct, and then you say inside of this there's going to be some number, which would be an int equals to, by default, some number, and then your number, maybe an unsigned int with 32 bits. So, and some value by default, that would be a struct. And then an enum, const my enum would be called enum, that like some choice 1, choice 2. So an enum would look like this. And then a union, const my union equals union. So like that now it's going to be like, let's say there's these two things, but it's then like a thing, a struct is you have the two things, and then you want to create one of those, you're going to say like my instance of the thing, my instance of my thing. You say like it is my thing, and I'm gonna say I'm gonna initialize it with my thing and put the values, some number equals some. And I can define it like this instance will have different numbers, and then so there's always be const, and then union is just one of the two. So if I want to do my instance of my union, like I'm gonna say it's my union, and I can define it to be equal to like you'll need to choose one of the two. Like one of these two, you can't choose both. But anyway, so that's just a preview. Like it's gonna always look like const and equal to something. So when you define types, it's gonna look like this: define enum, define unions. It's gonna always look const and then something. So this is defining, and the names. So let's forget about all this, just to like start over more simply. So this is our hello world again, and just print. And then there's this. The reason for this is because in Zig there's no like multiple arguments. Like you can't have different numbers of arguments. So every function, it's just it's always the same. So you don't have to think like which function will be used. So there's no, when you have a function, you can't overload it with different arguments. No argument overloading sounds like a big limitation, but actually it makes it very easy. So the var args, you have to put it in a tuple like this, and the syntax for tuples is with a dot, and then you can have multiple arguments. So I guess you can place here, like the interpolating strings is with this, and you could say hello with some number. So if I have a number here, it's going to be var my number. Let's say it's an unsigned with 16 bits or just 8 bits, like a U8, like that's a char. You can say it's equal to some number, and you say my number here, and another number, my other number, which like U64 or I don't know, like 64 bits, like you can have more space, so it's gonna be my other number, and then you can say something like that's my number, and then you can say my other number is equal to this other thing, and these two interpolations will be these two things in the tuple that I make. So the argument here of the print function, you can go and see it, like there's going to be a string, so that's a string here, this slice, we'll see that in detail, but like it's a slice of const U8, this is a slice of characters that we can't modify, and it's comp time, so we need to know it at compilation time, so we'll be able to check that the number of things in here matches the number of interpolations here. And args could be any type, but it's gonna have to be some sort of tuple, and we have to count, and these two will match these two places. So this looks like this. Boom. So I'm here, tag, my number is this, and other number is this. You'll see them in my little local view here, and then boom, you'll see the print worked. But if I like have a different number of interpolation, like I said, there's another one here. So what's gonna happen is at compile time, hopefully it's gonna find that there's not the correct number of things in there. See here, there are too few arguments in here to match this, and that was found at compile time, not runtime. That's cool. That's the main thing of Zig, is to be able to do many things at compile time. And yes, so let's just go really quickly into this. Let's look at the next one, std. Oops, this program is supposed to print a line. Yes, it's just, yeah, to show us that you need to write const here. Then assignment. Let's print this and try to fix this little program. Const n u8 50 n plus 5. So yes, you can't modify a const, it needs to be a variable. Const by, so this won't compile, it's going to tell us cannot assign to a constant, so we need it to be a var. Integer value cannot be coerced to u8, so this, yeah, this is too big for this, so it found it at compile time that it's too big. So it needs to be like bigger, probably u32, and have like any, like this also works, like that's a type, like that's 2 bytes. So this, if you try to give a 3, it's gonna work. Cannot cast negative value -1. Oh, it's this one. So this one needs to be I. So so not unsigned int, just int. So this is gonna work. But here you see 3, I guess a 4. That doesn't fit into a U2. U2 there's 2 bits. So that's gonna be 0, 0, 1, 2, 2, 0, 0, 1, 2, 3. So if you count binary, so 4 will not fit. It's going to say integer value 4 cannot be coerced to U2. Yeah, there are no errors. Yeah, so like this is just to show these 3 numbers that we made. So that was number 3. Let's go to number 4. Let's learn some array basics. Arrays are declared with this. So this is how we show Zig arrays. So this is an array. Print this. So we can show this. What happens there? Cannot format array without specifier. So I need to tell it how I want to show this. You see, it tells me like I can choose to try to see those as this as a string, and there's a special, like if I said like any, I guess that I need to make a choice on how I want to see this. So I'm gonna see the array like this. But I guess if I said S, will it work? Like that was the other choice. So I guess, yeah. So this type does not support S. It should need to be U8. So U8. I guess this one is too big with a smaller number here. Like it will be like a string. So those are the thing, but like U8s, you can write it like this, but you can also write it like a character. So I with this, so that's an ASCII, like these are the actual numbers. So if I say any, it's gonna be like this, but if I say with an S, it's gonna treat it as strings. So this is an actual string in Zig, or you really see that it's just, the type is this. So the fun thing is that the type has the length in it. So like the length is part of the type. And so I can, so this is how we could say it like this instead. So we declare a variable, and then we can assign it. So this does exactly the same thing, but if I try to not say undefined, it's gonna tell me that you're not allowed to do this. If you don't want to initialize something as you define it, you need to say like, I'm gonna define it really soon. So and the memory is just trash. Like that's an opportunity for optimization. So when we promise that we're gonna define it soon, so we need to define it. So yes, so but the normal way to say it would be like this. And if we see to the right of the equal something that makes it easy to deduce a type, so the compiler can guess the type by looking at this to the right. You don't have to actually say it. So this is the same because we saw it. And also, if you want the compiler to count for you these three, so that you don't have to say 3 here, you can say this. So this tells like the compiler, please count for me what's here, and you'll see it instead. So that's how to make a little string. There's easier ways, but it won't be an actual array here. But if you do just this, it's gonna look pretty much the same, but it's gonna be a string literal, which is something else. It's gonna be this memory for this string will all be not on the stack. It's gonna be somewhere here, like on the constant region of the program. So that was a little string, but there's more to it. There, like the type of this, it's gonna be weird, and it's subject for later. So let's continue. Like that was this. When Zig can infer the size of the array, you can use this. So that's what I just discussed. You can also let Zig infer the type and the value. So this is the same. So that's what we saw. Get values out of an array. Okay, we can get values out of an array. Let's go back to like this. Wow. Okay. So that was. Let's go back to an I32 and say ni and say 3, 4, 5. So little array like this, and I can say foo 0 equals to another number. I can say So that's how you set some things. That's how you can get and set the things. So you see the value changed. If I put a breakpoint and look at what it's going to look like here, see what it was. It's tells me where it is. There's the three things here. So that's cool. So next, so let's fix this little program. So that's a program with little errors. We'll find them. So problem 1, this sconce is going to cause a problem later. Can you see what it is? Probably we're going to try to modify it. So yes, it can be const, we're modifying it. So var. Individual values can be set with this. Example, this line changes the first prime to 2. Okay. This one will be set to 2. Individual values can be accessed with this notation. This line stores the first prime in first. Okay, some primes. So here, some primes. Okay, so like this is a U8. So you see, we don't have to do it because you can guess this, but I like to do it anyway. Then problem 2, looks like we need to complete this expression. Use the example above to set 4 to the fourth element of the sum prime arrays. So fourth, which is another U8, some primes, the fourth. 1, 2, 3, 4. One, two, three, four. So it's at the index 0, index 1, index 2, index 3. So it's the fourth one is at index 3. And use length property. So we have the actual length. So length is the U size. U size will be 32 or 64 bits depending on the size of things on your machine. And we get the length of the array. So length is actually like easy to get. So contrary to C or C++, you can get the length of an array here, even if this array is like directly here on the stack. And we'll see all this if it works. So this works on primes. This, okay, we still see this. First is 2. Okay, and then fourth, 7. Yes. Length, can we see length? No, we can't see it, but some primes, yeah, we can see the length, but the compiler knows it. And that's it, we saw that, so it worked. So next, we were working at the 4. Let's look at 5. Arrays 2. Zig has some fun array operators. You can use ++ to concatenate 2 arrays. Really? Okay. Let's look at this. Huh. A is this, B is this, and C is this thing. A plus plus B plus plus. Wow, we just create an array with just one thing in there. Error, unused local constant. So when we don't use things, it does complain because that's source of error, just doing something for nothing. Normally it would be an error. Don't do something if you don't use it. And the trick is just to set like this underscore equals to a variable, and this just says like at least we're kind of using it, but we assign it to this variable that is actually nothing. And yes, so it so we can't really see it. Like let's just print this. So we don't actually need this anymore. Yeah. Every time you have an array, you need to say, like, because it's a U8, it could be characters or any other thing. So yes, so we see it. So it would be like 1, 2, 3, 4, 5, 6. You can just concatenate arrays like this. That's cool. You can use star star to repeat an array. Really? Okay. Repeat an array like this. It will be this thing 2 times. Whoa, 1, 2, 3, 1, 2, 3. 20 times. One, two, three, 1, 2, 3, 1, 2, 3, 20 times. Oh, okay. That's interesting. And then let's fix this little program. Okay, so we have LE, it's this, ET is this. Problem 1, please set this array concatenating the 2 arrays above. Okay, LE plus ET, so it's going to be lead. Okay, bit pattern. We want this 3 times. So it's going to be 1, 0, 0, 1. Okay, bit pattern. Okay, that's all the problems. Let's see the result. Print, but let's have a little preview. Let's dig 4 loops instead. Oh, 4 looks like this. Don't worry, we'll cover looping properly in upcoming lessons. So print. I don't actually need this because I have print there. And it looks like this. Lead, print, n. So this is a for. So you loop on an array, get the element for each element, it's gonna put it in there between the 2 little lines here. I'm gonna print this. Then the bits, bit pattern, this guy, bit pattern, and print. So that's the fors. Lead, bits, bits. Okay. So that was easy. So that was 5. Let's go to 6. Now we've learned about arrays, we can talk about strings. We'll have already seen string literals, hello world. Zig stores strings as array of bytes. Const foo equals hello. It is the same as this. It's not exactly the same, but I guess as at first approximation it's the same. So let's just do it. Use the array square bracket syntax to get the letter D. 1, 2, 0, 1, 2, 3, 4. So it's 4. Laugh, ha. Aha. Okay. 3 times. Okay. Laugh, ha, ha, ha. Major thumb. Okay. Plus thumb. Major thumb. Now add a space as well. Okay. Then see all the problems, see our results. Okay, major thumb, that's fun. D equals D. Aha, major thumb. Keen eyes will notice that we put U and S inside the U because we want to see as print function to format the values as UTF-8 characters and UTF-8 strings. So those will be printed as UTF-8 strings and this one as a character. So U means a character. If we didn't do this, we'd see 100, which is the decimal number corresponding to the D character. Like if we didn't do that, would see that D will be equal to 100 instead of seeing it as a string. And the error in case of the strings, but I guess it could be any. Yeah, so we see actually this, which is a little bit disgusting. But okay, let's forget about that. So strings 2. Here's a fun one. Zig has multi-line strings. Okay. Zig has multi-line strings. Const lyrics equals, and the way that multi-line strings work is by doing this. So back, back, back. That's cool. Quiz time. Let's see if we can fix this whole program. What is this nonsense? Letters. Okay. Note, use size and aside integer type for sizes. Exact size depends on target CPU. Okay. There is a problem in this line. The size is in it. X, use size. See, X equals 3. So it can't be const. Note, when you want to declare memory, an array in this case, without putting anything in it, you can set it to undefined. There's no problem on this line. Okay. The following line will attempt to put ZIG into the lang array. Letters X1. Okay, it's going to be this one at first because X equals 1. So it's the first letter. 0 is at 1 here. X equals 3, so lang 1 equals letter 3, and lang 2 equal, the last one should be G. So 0, 1, 2, 3, 4, 5. So let's put it to 5. We want the program to program in Zig, of course. Expecting type 4, yes, this is again X again. Okay, so that's should print program in Zig. That's cool. That was 8. Let's go to 9. If. Now we get into the fun stuff, starting with if statement. If true, else. Okay. A equals B. B small. A smaller than B. B different than B. Okay. That's easy. Let's look at this. Please fix this condition. Foo. We want our program to print this message. Foo is 1. Foo is 1. Okay, so that's if and else. It's easy. 9, 10. If statements are also valid expressions. Wow. If are valid expressions. So it's like the question mark in C++. Who is a U8? If a 2. If some condition, 2 else 3. Okay, so we want to fix this little program. Price, please use an if expression to set the price. If discount is true, the bool. Is this a thing? Probably. If discount, we want to be 17, else 20. Yeah, I guess I don't really know. It's pretty clear that's the bool, like we see through there. Yeah, it's okay. So it looks like this. Boom. Okay. So that was if two. While looks like this. While condition equals false. Okay. While, please use a condition that is true until n reaches while n is smaller than 1024. Print the current number. Set n to n multiplied by 2. N star equal, so that doubles n. Okay. Easy. That was if 2, no, that was while. So while 2, extremely easy. The Zig while statement can have optional continue expressions. Continue expressions. Continue expression. I guess the last line here, you can put it right here. It's going to be the same thing. We just take the last line, we can actually put it here like this. So always it's possible to put, because the last line of some of time, like it's sometimes it's often a really special line that iterates and like increases the thing, so better to put it here because it's like a for, like the thing after at the end of a for in C. So that should do exactly the same thing. And their thing is like this. So that's the last exercise. So that's exactly what we wanted to see. So this is it. So yes, so 13, while 3. The last two exercises were functionally identical. Continue expression really show their utility when used with continue statements. Continue expression, continue. Continue expression execute every time the loop restarts, whether the continue statement happened or not. Okay. And n is 1. We want to print every number between 1 and 20 that's not divisible by 2 or 5. This is not divisible by 3 or 5. Modulo operator, and it returns the remainder after division. Modulo 3, so we continue. Because we don't want to print it, we don't want to end up here. And if it divisible by 5, continue. So when, like, this is the remainder after division by 5. So if it divides by 5, we're going to continue and continue here. And print only if it is not divisible by 3 or 5. So it looks like it works. So that was 13. 14 looks like you can force a loop to exit immediately with a break statement. Okay, break, that's it. Break, that's easy. Instead of continue, we get out of the loop. Oh dear, this while loop will go forever. Please fix so that the print statement below gives the desired output. We want n equals 4. So if n equals 4, break. When it's n equals 4, get out of here and don't evaluate this. I guess break means don't evaluate this, just break. And we want n equals 4, n equals 4. That's it. So 15, 4. Behold the for loop. It lets you execute code for each member of the array. That's what we saw before. For item, item. For items, item. Story equals H, H, S, and H. A dramatic story. Okay, for story. We get each character one after the other. And It's a scene. This is a scene. Okay. If scene is H, print happy, happy, sad, and neutral. Dramatic story. Happy, happy, sad, neutral, happy. The end. Wow. Beautiful story. 16. For loops also lets you store the index of the iteration, a number starting with 0 that counts up with each item index. Okay, item index. So we get both here, like this. You can name item and index anything you want. Item index. Okay, I can name it whatever I want. So let's store the bits of binary number in little endian on least significant byte first. Least significant byte first, so like the opposite order that we're used to when we write numbers. You will convert the binary bits to a number value by adding the value of the place as a power of 2 for each bit. So okay. So binary number in this inverted order means it's like when you multiply it with a corresponding power of 2, like ascending powers of 2, it's going to give us the value of this big binary number. See if we can figure out the missing piece. Okay, place value, the value of this place, this should be like 1, 2, 4, 8. I. See this I here? Convert the U size U to U32. So, oh my god. It's I. std_math_pow. Pow wants a type first, so pow needs to like work on a specific type, and I is a size, but this is a U32. So we int cast place value times bit. Note that for loops also works on things called slices, which we'll see later. Okay. It kind of, I think it worked. Let's see what it looked like. So bit equals 1, I equals 0, so place value is 1. So next one, the place value will be different. Place value, can you tell me what the place value is? Place value 2, place value 4, place value 8, and depending on the, if we multiply it by the actual bit. Okay. I think we understand this. It's kind of sad to have to do this. Int cast, it's not really clear, like converts an integer to another integer while keeping the same numerical value. Tempting to convert a number which is out of range of destination type. Okay, so that was 16. So a quiz time again. Let's see if we can solve the famous FizzBuzz. Okay, FizzBuzz, no problem. Let's do FizzBuzz. What kind of loop is this? A for or a while? So this looks like the while, even if it looks like a for in C. Okay, start at 1, stop at 16. If modulo 3 we want to print fizz, modulo 5 prints buzz. If not this one and not this one, we want to show fizz buzz. Is that it? Replace any number divisible by 3 with fizz, any number divisible by 5 with the word buzz. Print the thing here. we want to print the number. Like we need to replace with the actual number. So let's show fizz, buzz, and then just the number. So which is I. And then, so yeah, so the hard part was to just like, you actually need to do this thing again. One, two, fizz, 4, buzz, fizz, 7, 8. Fizz buzz is only for the 15 that both of them wrote their thing. Okay. '18 functions. Functions. We've already seen one called main. Let's try writing one our own. So this is how you write functions. So this is how we write functions. The new function deep thought should return the number 42. See below. Answer deep thought. Call this. Could be like, so it needs to be fn deep thought, and it returns a number. Returns this U8 number. So this should just print 42. Yes, this could be at the top. Could be like the order doesn't matter. You see, like all the declarations in a file are like in any order. I could even put this at the end, I guess. Does this make sense? So you can literally put everything in any order you want. Even like this, like std is like we use it here, but it's declared after that. That's very strange, but it works. Like you're allowed to do this. Okay. It was function, so function 2. Now let's create a function that takes a parameter. Okay, functions, parameters, looks like this. Boom. So we have a main, and we have 2 to the blah, blah, debug print, powers of 2. 2 to the 1, 2 to the 2, to the 3. Please give this function the correct input parameters. 2 to the, we give it like these numbers. It's, I guess, U32. Don't really like, yes, we want U32s. So it's going to be called my number because that's what it's written here. And the syntax is this. Type after. Like all the new modern languages, type is always after now, like contrary to C and C++, because the reason for the type being after is like it's because yes, so there's always at the front there's going to be const or var, and yeah, and this can't change, and sometimes the type is inferred, so that's easier to make it. Like, so the syntax for inferring works better if it's after. Now it takes a numeric type and 2 numbers of that type, a to the power of b, 2 to the my number, powers of 2, blah blah blah. Okay, functions quiz. Let's see if we can make use of some of the things we learned so far. We'll create 2 functions, one that contains a for loop and one that contains a while loop. Both of these are simply labeled loop below. Okay. Main my numbers, print. Okay, let's forget about this. My numbers. Okay, 4 little numbers here. Print powers of 2. Get as argument this. So you see the argument is this. That's the type. And we loop, but loop is not a thing. So we need 4 for these, 4 to loop on these. And we return what? We return nothing. So we return void. And then this function bears a striking resembling to the 2 to the, and it returns U30, U16. And this is a 1. And that was a 4, this is a 1. and we return the total. Yes. Okay, yes, makes sense. Those are the numbers we wanted. Int always have two. So you see that's we call a function, call the function again. That's what it looks like. Okay, let's continue. Errors. Believe it or not, sometimes things go wrong in programs. In Zig, an error is a value. Okay, so when a function has an error, it returns the error instead of the result. Errors are named so we can identify things that can go wrong. Errors are created in error sets, which are just collections of named errors. So I guess without that's an enum. Just let's look at enums before. My enum, and I say it's my enum. Enums look like this, but if I call it like error, like one thing, like instead of looking at this, this error, let's look at like how we would design an error system without exceptions and just like unions. So like my error could be like no internet or no like no power or like file problem, like all the problems that you could have. Like it's just an enum, and maybe a function would return this. So let's say my function wants to find the something, like find something, and we want to put it like in, like have the result, like so we'll have like a union, my result or error. It could be a union. So a union with two choices could be either the error, like the error, or the result, which is my error, or the result, which is, let's say, a 932. So like the goal was to get a number, the result number, or an error, like, or here see, like no problem, no error, no error, like success. Like now we return, no, it's not success, it's just, it's either this or this. It's like a union, it's not a struct. but I guess you could make it as a struct. So like let's instead make a struct to make it a little bit simpler. So we have struct and we like success. This now like find something would return my result or error, and we would return, let's say in some cases, like if 3 is bigger than 2, we would like it worked and we're happy. We return my result and maybe error. Return my result and maybe error, and we make it like this. So we need to set the error. The error equals, and the way we say it is like this with the dot. That's how you initialize a struct. Error is my error, no internet, and the result number equals 0, but that's just garbage. In case of an error, it's the result number is 0. So or else we return it worked. So the result number is 42 because it worked, and my error was actually no error, so it's just a success. So that's how you would do this if you didn't have errors. Like you have an error minimum, but then result number like this. So we need this. I need one of these and one of these here. So result, it's my result or error, and then we call the function, find something, and then print the result. I don't know. So that's how the results are, or maybe error.
Papa, c'est une journée. Regarde.
Allô.
Je sais pas comment ça mais.
Bonjour.
Non.
Salut, ça va?
C'est
Vous
vrai.
avez les cheveux longs maintenant? Bon, vous avez des skis, allez, on va aller dehors?
Regarde.
Ouais, merci. Bon.
Oh, tu es un petit
Il ne pas.
T'as pas bon. Il a mis dans ma chambre. Il est noir.
So yes, so if we didn't have errors and like the little syntactic sugar that Zig has, it would look like this, and then you would use the result. Like I need to use the actual result, like result or error. Now I need an actual result, so I would say var the actual result, like result, which needs to be a 932 because this is what I actually wanted, and I would say equals result or error dot the result number. But I would do it only if result or error dot the error equals my error success. So if there's no error, I would do something with it. And if I'm in some function here, I'm in some function that does something, blah blah, and a function that returns an actual I32. Like let's say if I need to return I32, blah blah, it's like blah, add 3 to result of other function of find something. Like the goal of this function is to add 3 to this, and if like let's call this, so it's gonna call this, and let's say this function here, like if find something failed, if find something failed because there was no internet, I want this function to decide to do something else, and so it failed. So we're gonna guess. So we say that the result should be equal to something else, to 0 instead, like, or to like default value. Like the default value is, let's say, 23 instead. Okay. DNI 32, and so that's my default value. And if we had a success, now we just use the result instead. The result of find something. So like this is a function that uses a function that could error. And the way this guy decides to do it is by having a default value, and if it was a success, then you do this. Error success, you use it in this case, and then you can return it. So that's one way of dealing with a function that errors. So this guy decided like result plus 3. Add 3 to result of find something. So we're like the result of find something plus 3. So now we can just call this. And so in this case here, what will happen? So let's look at this. So we go in, and we find that it's an error. Like we had a problem. The error is no internet. So here, the result or error, the result is some number that we don't care about because the error is no internet. So result is 23, and here we're not equal to success, so we don't go in there, and we use 23 plus 3. But in the case that we don't have an error, so if 1 is bigger than 2, like it's like so if we don't have an error, we return the actual result, this guy, in my little struct here. So that's how people would do it. Like they would like always return little structs or unions if there's a tagged union. And here, like we would get, instead of 26, it's going to be 42, because we're going to actually, the error is success here. Boom. So we're in here, the result is 42, and 42 plus 3, 45, and we print 45 here. So everything in Zig is to try to make this, I guess there's another way, like this other function could say, yes, I want to return, like if there's a problem, I want to just add 22 to result to find something, but don't fix the error, don't guess the default, and just return also the result and maybe error. So I would do this and not do this, and try to result or error. Like I'm gonna like my result will actually be if it worked. If it doesn't work, you see like if it doesn't work, what I want to do is return like what we got, like just directly return result or error. Boom, immediately. That we like if it was an error, we just return it like this. But else we just take this that we got here, result or error. Here we're a success. If we're here, it means it was a success. I'm gonna go here and I say the result number plus equals 3, and then return it. So that's another, like, don't fix it means like if there was an error, just return it. So what does it looks like if I do this one instead? So we got my result and maybe error. The error success, the result number 45. So here, and if there's an error, it's gonna return immediately and not do the rest. So this, we just get out. And every time we would like call something that can have an error, you need to check if it's an error. And if it's an error, you just return the thing. So this would be there everywhere. And this is, now we're going to change it to the actual error. So instead of doing this, my error, if we just write here, error, it does exactly the same thing, does it? Maybe not. No, it's actually giving the same result. Boom. So it's like, it's literally like this little thing is is just like an error. But then my result and maybe error, this thing we can change it and then use Zig syntax of saying my error or I32. So like what I just did here with this little exclamation mark is the same thing as doing this. So this is this. So I return the error. So this means I can return one or the other. It's more like a union. This is literally a union with the first thing being an error. So this is this, but not struct, like more like a union, like it's really one or the other. And in this case, we don't need success. And we got an error. If we get an error, we return the error immediately. Like so, let's say it was this error that we got, we just return it. Boom. Looks like this when we get an error. And when there is no error and we want to return the result, we just return 42. We just return the good result. So that's literally just sugar for like to return either an error or the number. So that's what it did. It's the same thing as what I did before. And then the function that wants to use this, so we're gonna just call find something. So this is like this. Is this legal? I'm not sure. And maybe let's forget about this and just return 3 for now. Does this work? Probably not, because errors are different. And then this is not really legal. Am I allowed to do this? Probably not. Unused local variable. Oh, maybe I'm not. Error error is discarded, so I'm not allowed to do this. You see, like this is what like is actually happening. So when I call this, when this function wants to call my function that can have an error, I need to do something with and decide something. I can't just take it result or error. It's like this. You can't actually put it in a variable. You're not allowed. You have to deal with errors. So you need to decide. So every function that wants to call this has to decide if it wants to have a value by default or just throw the error up here and also do something. So like here, instead of doing this, you'll need to so here what's happening, let's say I'm doing this and like I want to do like if result or error is an error, like if it's an error, I want to do something. I want to do like take care of it, and I want to do something if it's an error here. But the Zig way of doing it is not like this, because this is already too late. You're not supposed to just put it in a variable here, continue like playing with this, because you need to deal with it immediately. And this is like catching the error, and that's why there's this syntax that I actually want the result immediately. Like the result is an I32 and find something, and this like result plus 3. We're trying to add 3 to the result. This is what I actually want to do. Like it's supposed to look like this. That's what I actually want to do, but I want the result to be like the I32. But here, expected type I32, but found this. So now we need to actually deal with the error, and the keyword is catch. So find something, catch, and then give a block. And do something, and decide a value for result. So I'm gonna say catch, and just I need to catch it, and give us something as a for result. So maybe not a block, just a number, a catch, and I said the default value was 23. Here you see default catch 23, catch 23. That's fun. Catch 22. 22 is better. Catch 22, and this is legal. This replay, if it's an error, we're gonna catch the error and put 22 instead in result. So we got an error, true, boom, 25. So that's what happened there. Get in there, got an error, return this error, boom, yes, and then yes, I need to go now, but I guess if you want to just don't want to deal with it and just error, you can put this like this instead. And then instead, just try it. Like, let's say I catch it, and then catch the error, I guess, and push it. Okay, so that's it.
Tu peux, Gabo,
So, bye.
il y a la famille,
Bye bye.